So let's start recording from the next sum. The next sum is the 9th sum in Nanda's paper, PS senior paper. So black color. So it's mod of x plus 3 plus x by x plus 2 is greater than 1. Let's take the 1 to the other side, because I feel when I take LCM, it's getting solved beautifully. Okay, by x plus 2 minus 1 is greater than 0. So mod of x plus 3 plus x minus 2 by x plus 2 is greater than 0. This and this is getting cancelled. The function becomes a much simpler function. Minus 2 by x plus 2 is greater than 0. Now I want to redefine this function. Why I want to redefine this function? I could have also approached it as find the cutting points and then do the numerator and denominator. I am not able to. So for even to find the cutting points, yes, even to find that, I need to just decide this interval. This is a graph when at minus 3 it's becoming 0. So when x is lesser than minus 3, this is minus x minus 3 minus 2 by x plus 2 is greater than 0. If x is greater than minus 3, it will be x plus 3 minus 2 by x plus 2 is greater than 0. So it's minus x minus 5 by x plus 2 is greater than 0. And here it's x plus 1 by x plus 2 is greater than 0. So you can take the minus out, common x plus 5 by x plus 2 is greater than 0. So I'm going to do a line here. I'm going to determine my cutting points, or what you call critical points, which is minus 2 and minus 5. And give one example on the, this is minus 3, this can be minus 5 has to be here, the same mistake, minus 5 and minus 2. So this has got to be minus 5 and this has got to be minus 2. Give an example here, let's do it in red color. A red color example is minus 6, minus 3 and a 0. Giving this here, let's see if it's satisfying. When you put minus 6 here, minus 6 plus 5 with the outside minus become positive. The denominator is become negative. Positive, denominator is negative. Is it greater than 0? No, it's becoming a false statement. When you put minus 3 here, positive but yet negative. Negative and negative makes it true. 0 if you put, it's negative and positive. So it's false. The advantage of doing the sum like this, and it's true only for this interval. And done. Minus 5 to minus 2. But however, there's a predetermined condition that x has to be lesser than minus 3, and the minus 3 will come here. You know the minus 3, I'm going to write in black color. The minus 3 is anyway coming here. So therefore, my answer is not till here to here, it's here to here. So my x is an element of minus 5 inclusive till minus 3 inclusive. Can I include minus 3 inclusive? In one place I can include, one place I can't include. In this I have not included, in this I am including. So then therefore here I will not include. I'll write it with an open bracket. That is sorted. Let's go to next one and decide on the cutting points or critical points, which is minus 1 and minus 2. Let's give an example before and after. This is minus 3. This example will be minus 3 by 2. This example can be 0. On putting minus 3 on the numerator and denominator in this formula, negative of negative will become positive. Is greater than 0? True. When I put minus 3 by 2, the numerator will become negative. Denominator will become positive. So it's becoming false. When I put 0, both of them are positive and positive. Yes, it's greater than 0, so it's true. Therefore, I understand that this interval and this interval satisfy. There's a predetermined condition that x has to be greater than or equal to minus 3. Let me include that somewhere. The minus 3 is anyway here only, no? So it limits my answer not from infinity, it's coming. It's from minus 3 to minus 2. And I can close this because I included a minus 3. And I can include can I include a minus 2? Denominator is becoming 0. So I can't include a minus 2. And I can, minus 1, can I include a minus 1? Yes, I think I can include a minus 1 till infinity. And union of this, that's the answer. Is the answer correct? Huh? Yeah. So are you supposed to combine these two answers and write one single answer? Is the question, correct? Okay, I have got this answer and this answer. So I'm going to combine these two answers and write. Let's draw a combined graph. Yeah, and this is minus 5 here, minus 3 here, minus 2 here, minus 1 here, infinity here. So let's do this. Minus 1 not inclusive, is it? Minus 1. Why minus 1 not inclusive? Greater than 0. Why? Because it has to be greater than 0. If I put minus 1, the numerator will become 0. So I can't include minus 1 also.
Yeah.
Open bracket minus 1 till infinity. Minus 3 inclusive. Till minus 2 not inclusive. Correct? These two are these graphs. Let me do this in different color. Minus 5 to minus 3, where this is not inclusive, whereas this is inclusive. So basically you combine all these answers and write it. Not inclusive in this, but however here it is inclusive, no? Here it's not inclusive, but you can include it. I know you can include because you put minus 3 in the question. You put minus 3 in the question. Minus 3 plus 3 is 0, but you still have a minus 3. Minus 3 plus 2 is minus 3 by minus 1 is positive. Super. So you can include minus 3, and if you have a doubt you can see that, and hence you know that this answer is going to be from minus 1 to minus 5 inclusive to minus 2 not inclusive. Union minus 1 not inclusive till infinity. That should be the answer.
It says 1.
Union. It's minus 1, no? X is greater than minus 3.
I guess it's mistake here.
Yeah, so minus 1, correct?
Yeah.
That's okay. So then that's fine. This is the way you have to answer this question. Let's go to next question. Question number 11, is it? Is the mod of 2 by x minus 4 is greater than 1. Greater than 1, okay. So whenever I have such questions, you will ask me, you will take it to one side. I can't take LCM now. I can't take LCM because this is within the mod. So I will not do like that. I will first do 2 is 2 only. 2 has got no negatives and positives and all. 2 is 2 mod of x minus 4 is greater than 1. You write like this. So now also I can't take LCM because when I take LCM there's a mod which goes as LCM. So LCM method I am not going to do. Correct? So what else can I do? It's greater than 1. So just cross multiply. Just cross multiply. Therefore 2 is greater than mod of x minus 4. So mod of x minus 4 therefore lesser than 2. So you know if it's lesser than 2 it has to be greater than minus 2. So a mod x minus 4 is lesser than 2 and greater than minus 2. Take these inequalities and solve. You get x minus 4 is greater than 1 second, hold on. So x minus 4 is greater than minus 2. X is greater than minus 2 plus 4 is plus 2. Taking this x minus 4 is lesser than 2. X is lesser than plus 6. So you put it on the number line, x is greater than plus 2. X is lesser than plus 6. So then it's open bracket 2 comma 6 is the solution. And however, x is greater than 2 and x is less than 6. Yeah, so you got this. You got this because you considered like this and you did it like this. A simple method you have done. However, if this is greater than 1, it can't be decimal numbers. Did we even verify for those? We didn't verify for this. If it has to be decimal numbers, the denominator mod of x minus 4 should also be greater than 2. It's greater than 1, should not be. Should be lesser than. Should be lesser than 2 because you know if it's greater than 1, denominator should be lesser than 2. So is that what I wrote here? Yeah, that's what I analyzed here, which is fine. That x minus 4 has to be lesser than 2 is what I've analyzed and I got this answer, correct? Greater than 2, lesser than 6 is all I got. Okay. But you know that in this question, the denominator cannot be 0. In the number line, I should write a 4 and I should make sure that it doesn't include 4. Therefore, my answer should not include 4. Cut it 2, 4, union 4, 6 with an open bracket you write. That's all. So it's fine. So let's go to next sum. Next sum is the sum 12th sum, I think. A mod of 2x minus 1 by x minus 1 is greater than 2. So they are simply taking it to the other side, thankfully, because it's greater than 2. See, I can't take it to the left side, put minus 2, I can't take LCM, so I can't do that method. then I can't predict it's a positive, it's always greater than 2, which means this is going to be positive numbers only, but you can't get a 1, you can't get a 0.5, so it's so confusing, therefore cross multiply. So 2x minus 1 is greater than 2 into mod of x minus 1. Then in this sum, they are just taking and squaring both sides here. Okay, 2x minus 1 the whole square. Why? Because this can be done, the squaring both sides can be done only if it's greater than 2 or any only positive numbers. Because in that case you will get x even when you square, it's only positive numbers. I don't know what I'm saying only. 4 into x minus 1 the whole square, just do that. So then you expand this, 4x square minus 4x plus 1 is greater than 4 into x square minus 2x plus 1. On solving this you get 4x plus 1 is greater than 4, 4x is greater than 3, x is greater than 3 by 4. And you already know x cannot be 1 in such mod function. That's something we forgot last time itself. You put it in the number line 3 by 4, there will be 1 here. You know x cannot be 1 and it's greater than 3 by 4. So you have to cut it and write 3 by 4 to 1 and then 1 to infinity. Anything else that cannot come. Okay, so you understood that you can get answers from 3 by 4 to open bracket 1 and you can get answers from 1 to infinity, correct? So now let's take the cutting points. What are the cutting points? Okay, what is this sum? Sum is never ending, okay? But anyway, let's take the cutting points. 1 second. You should understand that x cannot be half from here since x is greater than 2. Again, this can be only a JE's question. Normal people can't solve this problem. If x is equal to, recording. If x becomes 1 by 2, 2 into 1 by 2 minus 1, 1 minus 1 is 0. It's becoming lesser than 2. So you know 1 by 2 on all those regions cannot even come. Therefore, I can't include a 1 by 2. Where will 1 by 2 come? There will be 1 by 2 here. I can't include a 1 by 2. Can I include numbers from 1 by 2 to 1? Let's see. Let's give 1 by 4. Put here. 2 into 1 by 4 minus 1 by 1 by 4 minus 1. Just 2 into minus 3 by 4 by a minus 3 by 4. It's becoming 2, but it has to be greater than 2. But so you cannot put 1 by 4 also. Can I put 1? If I put 1, 2 minus 1, 2 minus 1 is becoming 1. I cannot put 1 also. So all these values I am not able to put. The values which is lying between half and 1 I am not able to put, right? I am not getting an answer, right? Why the hell I am written here? So I can put only 3 by 4 to half. Half to 1 I am not able to include. Then 1 to infinity I am able to include. I have to verify this answer. Okay, so this sum, you might wonder, why did I square both sides and do it? Now, how can you allow to do squaring both sides? You know, which means aren't we ignoring complete negative? So this is what is given in the net. What I would do is this, where I'll redefine the functions. Okay, I'll mark the cutting points or the critical points. Denominator is 1. Denominator cannot be 1, so I'm putting around. Numerator is cutting critical point is 1 by 2. So giving an example, I'm redefining the functions like this. You can also see where it's true and false. You see, I'm getting here x is greater than 5 by 4. But I know this is the condition where it is already greater than half and lesser than 1. Okay, so between this it has to be greater than, is 5 by 4 greater than half, it's lesser than half, right? So at half this is a cutting point. I cannot include because this itself is greater than this condition itself on the basis of half to 1. So it's 5 by 4 to half. A union 1 to infinity should be my answer while redefining. Whereas you see this answer that I got, it's greater than 3 by 4 to 1 by 2. But I am getting 5 by 4 to 1 by 2. When I don't square, is there anything wrong in this? Let's see. 4x plus 5. Correct? Yeah, there's nothing wrong. This is what is the accurate answer in my opinion. You can all check out. The squaring is getting me different answers, slightly varying answer, but I'm not agreeable to it. I feel this is a better answer. So there I'm getting 3 by 4. And you know 5 by 4 is greater than 3 by 4. I'm trying to find somewhere midpoint between these two. It is 8 by 8, which is 1. And you know the answer, it cannot be 1. So definitely this answer only is correct, and the internet answer which has been given in ChatGPT where they're squaring, let's not adopt that squaring method. I am not agreeable to it. Let's redefine the function. I hope you're clear. So let's go to next sum. So next question is the 13th sub question, which is mod of x minus 1 by x plus 2 is lesser than 1. You know denominator cannot be 0, x cannot be minus 2, first itself you know. In this I'm allowed to take it to the other side because I can take LCM. You can understand where I'm doing. So mod of x minus 1 by x plus 2 minus 1 is less than 0. When you take LCM, mod of x minus 1 minus x minus 2 by x plus 2 is less than 0. What is the use in doing it? Okay, let us cutting point. You know, for this the cutting point is, let's redefine this mod function first. To redefine this mod function, I'm going to consider that x is lesser than 1 and x is greater than or equal to plus 1. So this becomes negative minus x plus 1 minus x minus 2 by x plus 2. So the function itself is minus 2x minus 1 by x plus 2 is less than 0. Let's look at this. In x is greater than or equal to, so it will be x minus 1 minus x minus 2, where x and x is getting cancelled. I am getting minus 3 by x plus 2 is less than 0. So this is based on this precondition. I am redefining the mod and writing the answer. Now this I'll put the critical points, decide positives and negatives. I hope you understood. So what are the critical points? If you take minus sign out common, it will become 2x plus 1. X will become minus half and x will become minus 2. So minus 2 will be here and minus half will be here. You are supposed to give one example before and after. Let's use red pen and give examples. Minus 2 means minus 3. Between minus 1 and 0. So putting this, I'm going to decide whether it's positives or negatives. Minus 3 if you put minus 6 plus 1. Negative, negative, negative. Numerator is positive, denominator is negative, less than 0, true. Correct? Let's go to next one. Minus 1 if you put negative, positive, negative, negative, positive, positive plus positive, 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 false. So this you need not even consider. Let's take 0, put it here. 0 means it's negative, 0 means positive. So negative by positive is negative, is less than 0, so true. So 0 to infinity is okay. So you understood that whole condition is in minus infinity till minus 2 is okay. And then minus half, what is this? Minus half, no?
Yeah.
Minus half to infinity is fine. But however, there's a predetermined condition that x is less than 1. Put that here. 1 will be here, no? So it will limit itself to 1. So union of this is the answer for this. Minus half to 1 because there's a predetermined condition which I have to check. Okay, I've checked it here and I put it. Now let's go to right hand side. In this right hand side, you know x cannot be minus 2. That we all know. And here I've been not included minus 2. Cleverly I've not included, so fine. Look at this. How are we going to do this? The cutting point is, there's no mod functions, just deciding whether negative or positive. Cutting point is minus 2. Left side given example, minus 3. Right side given example, 0. Put this example here, minus 3. It will be negative, mainly negative, denominator also negative, so it's positive. So negative by negative, positive is less than 0, so it's false. Here 0 if you put, it is becoming negative by positive, so true. So this, according to right hand side, the answer is only from minus 2 to infinity. However, the predetermined minus 2 to infinity, there is a predetermined condition that x has to be greater than or equal to 1, and x cannot be minus 2 also. X cannot be minus 2. Correct? And what did I say? X has to be greater than or equal to 1. 1 is only here, na? X